Alright guys, so now we are basically doing exactly what we did in example 6, except this time we are adding one more part. Okay, not only after we decide what the multiplicity is, like we did in the previous problem, we're going to determine what the graph behavior is at each zero, which we talked about this on the Prezi, as well as we did a nifty activity to determine when we'd have a tangent zero. So remember, tangent is when the graph kind of bounces off. So if I draw a picture of a graph, which I'll draw it down here. Alrighty. Alright, the zero. So you're looking at the x-axis when you determine this. Okay, if the graph just kind of crosses on through the zero, like this one's coming, and bam, it just keeps going through the zero. If that's the case, it has odd multiplicity. I'm going to abbreviate that. So odd multiplicity or an odd exponent will make the graph cross through. And if the graph kind of bounces off the zero, so you guys see it kind of comes down and bounces off, it's like boing. Okay, that's called being tangent at a zero. Okay, and this is when it's even multiplicity. So even multiplicity is tangent at the zero, and odd multiplicity just crosses through. It doesn't really have a name for it, so cross through. So that's the only thing that's different. So if you think you can handle this, go ahead and pause the video and try it on your own and fast forward to the end and see if you get it correct. Alright, so our leading coefficient, that's the very first number we see in front of our very first x. Okay, so here I have an x that's in the very front. Okay, so the number in front of the x, I don't see a number, which means secretly a -1 is there. Holy hot dog, so my leading coefficient is -1. Alright, zeros. As many x's you see up here is as many zeros as there will be. So I see 3 x's up here, which means there will be 3 zeros. And everything that has an x involved with it has a zero. Now this one, I don't really see anything added or subtracted to this one. Okay, so I can't really take the opposite, but if you see an x by itself, just like this, okay, if nothing is added or subtracted to it, when an x is by itself, you guys, it's like an x minus 0. Okay, so whenever an x is all lonely and by itself, like this one, the 0 is going to be 0. Okay, so my first 0 for this one is x equals 0. Alright, now my second one, at x minus 2, we're going to change the sign, so at -2, it'll be x equals +2. And my last x I see a +5, which means my 0 will be the opposite of that, which is -6. Awesome, awesome. Okay, so now the multiplicity, that is the exponent on each 0. So the exponent when x is 0, the one that this one pertains to is the x, and I don't see an exponent, which means there's secretly a 1 there. Okay, so the multiplicity on this one is a 1. So the multiplicity is a 1. Alright, now on this one, when x is 2, that's this factor, and the exponent on that factor is 2. So this one, the multiplicity is 2. Alright, and on this one, you guys, at hold on. Why did I write -6? Sorry, guys. When it's +5, the opposite of +5 is -5, which at this point, I can't remember if I said +5, or I can't remember if I said -5 and wrote -6, or if I said -6, but I guess the demon cat's got me, so sorry, guys. They always get the best of us. I did it again. Jeez, Miss Long. This is super embarrassing. What's wrong with me? Okay, +5 is -5. Good golly, Miss Molly. Okay, so -5. Finally, I can write a -5 correctly. Okay, so at -5, the exponent is going to be a 4. So the multiplicity is a 4. Alright, now the graph behavior. This is when we decide. Okay, it's kind of cool. We can predict kind of what the graph's going to do without even looking at it. And if it's an odd multiplicity, so if this number is odd that we just listed, it will cross through that 0. And if my multiplicity number is an even number, it will be tangent at the 0, which means it will bounce off. So we're looking for the phrases cross through and tangent. So let's see what happens. Okay, since this number right here, the multiplicity is an odd number. So when x is 0, it will cross through the graph. So I'm going to write these answers kind of right under the 0, so it kind of is associated directly with my 0. So cross through. Okay, at x equals 2, the multiplicity number is an even number. So this one's going to be tangent at that 0. Alright, and my last one, you guys, at -5, the exponent is an even number, which means the graph is going to bounce off that 0 or be tangent. Okay, so we kind of already know what the graph's going to do at the 0, which is really awesome in my opinion. Really awesome. Okay, so my graph behavior is up here and it's listed in orange. Okay. Alright, you guys, and finally the degree. Remember the degree in factored form, we add up all the exponents. The degree in standard form, we pick the highest exponent, so be careful. Alright, guys, so the degree, I'm going to add up all my multiplicities, or all my exponents. So I have a 1, a 2, and a 4. So 1 plus 2 is 3, plus 4 is 7. So this is degree 7. So basically, you guys, if you sat here and you like multiplied all this stuff out, your highest exponent would be a 7. Cool beans, right?